So I'll be discussing about the machine learning topic, which is going to be called XGBoost. What is XGBoost in general? So XGBoost, or Extreme Gradient Boosting, is a distributed open source machine learning library that uses gradient boosting decision trees, a supervised learning boosting algorithm that makes use of gradient descent. It is known for its speed, efficiency, and ability to scale well with large datasets. So here's a very good example of a XGBoost, which is going to be the decision trees. You might have seen this in math called tree diagrams, where you try to factor out the LCMs and all that good stuff. It's kind of like the same concept, but it's going to be a little bit different for this. So how does XGBoost work? It builds decision trees sequentially, with each tree attempting to correct the mistakes made by the previous ones. The process can be broken down as follows. Step 1 is to start a base learner. The first model decision tree is trained on the data. In regression task, this base model simply predicts the average of the target variable. The second step is calculate the errors. After training the first tree, the errors between the predicted and the actual values are calculated. The third step is called train the next tree. The next tree is trained on the errors of the previous tree. This step attempts to correct the errors made by the first tree. And then we got the fourth step, repeat the process. This process continues each new tree, trying to correct the errors of the previous trees until a stopping criterion is met. So if we meet a condition kind of thing. And then the final step is to combine the predictions. The final prediction is the sum of the predictions from all of the trees. So that is the idea of how the steps for XGBoost work. Now I want to talk about the difference between a decision tree and boosting. So a decision trees are used for classification or regression tasks in machine learning. They use hierarchical tree structure where an internal node represents a feature. The branch represents the decision rule, and each leaf node represents the outcome of the dataset. And then for boosting, it combines multiple individual weak trees, that is, models that perform slightly better than random chance, to form a strong learner. Each weak learner is trained sequentially to correct the errors made by the previous models. After hundreds of iterations, weak learners are converted into strong learners. So you can see on the top left right here, you can see this decision tree, or you might know it from math, right? So how this works, this decision tree, is you'll be given data, and then you're going to be like deciding what it does. So here, let's just say you're able to fly. So if it's true, it lays eggs. If it's false, then it has feathers. So let's just say it was true. Now the next thing is, does it lay eggs? If it does lay eggs, then it's going to be a bird. If false, it's going to be a mammal. So it's going to take in the data and try to decide whether it's true or false until we reach a specific condition based on the data. And then likewise, vice versa. If it's false, it has feathers. True, it's going to be a bird. If false, it's going to be a mammal. So it's kind of like that concept for decision trees. And then this example here, you can see here that for boosting, you're basically just adding up these weak trees and trying to combine it into a strong, powerful tree that can be able to function using some of the stuff that is essential needed for this decision tree. So you're just trying to make weaker trees into a stronger tree, a stronger decision tree. And then now I'm going to show you some examples of XGBoost. So to set it up in Jupyter Notebook, I'll assume that you already created your environment in your shell or terminal. You're just going to put in conda activate, whatever your environment name is. Now to install XGBoost, assuming that you don't have XGBoost, you're just going to put in pip install XGBoost. So when you do that, after you got that installed, you can just close your terminal or shell, or PowerShell, I should say. And then just put in your conda activate environment, and then just put in your code for Jupyter Notebook, assuming that you already installed Jupyter Notebook. And I'll be showing you some examples. So right here, we have some code related to XGBoost in Jupyter Notebook. So the first three, what we did was we just imported the XGBoost, the iris dataset, and also the function that splits the data into training and testing sets, which is this code right here. Now for the load data, which you can see right here, what it is we're going to do is we're going to load the iris flower dataset, And then X contains the features and Y contains the flower species labels. And now we're going to do is we're going to split it and test it. So we're going to split the data so that the model trains 80% and tests on the 20%. The setting random state basically makes the results reproducible. And now for the training model, what we're going to do here is we're going to create an XGBoost classifier and train it on the training set in one line, which is right here. And now to show the accuracy, we're going to test the model of the unseen data and print the accuracy, which is basically the percentage of the correct predictions. So when I run this code, you'll see right here that the accuracy is 1. So that's basically how this works. Now to sum up what this code did right here is the code loads the iris dataset, trains the XGBoost model, and prints how accurately it predicts the flower types. So that is what that first code did. All right, so for the second one, we are doing a code related to the wine dataset. So I'll explain piece by piece of what each code did. So right here, the first for what we did was we just imported the XGBoost, the wine dataset, a function to split the data, and the accuracy score to evaluate the model. Now, what the load wine dataset does is we just loaded the dataset, right? And then we just load in the wine dataset where X contains the chemical features in the wine and Y represents the wine class labels. And then where you see split, what we're going to do is we're going to split the dataset so 80% is for training and 20% is going to be for the testing. And then the random state keeps the split consistent every time. So this right here, the random state, it will keep it consistent. And now what we're going to do is we're going to train the XGBoost model. Now we're going to create an XGBoost classifier and train it using the training data, where XGBoost builds many small decision trees and work together to make an accurate predictions. And now to make the prediction, we're going to use a trained model to predict the wine classes for the test set, which is right over here. And then when I put in the accuracy, what it's going to say is how much accurate it is from the real to the predicted. So when I put it right here, what it's saying is it is 94% correct compared to the real list of labels. So to sum it up, this code, what it did, it was this code loads a real wine dataset, trains an XGBoost model, makes predictions, and prints how accurate it classifies the wine samples. So those are the examples and basically how XGBoost works in Jupyter Notebook. Hope you all have some ideas of what you guys want to do in XGBoost, and happy coding when you're doing XGBoost in Jupyter Notebook. Have a good day.